Hello everyone. So let's see this problem. This is a very famous problem. So we will see three kind of problems in that. So this is a cube given to you, and each branch like all of these branch represents a resistance R. Okay. So first we need to find the equivalent resistance across diagonal. Then we will find the equivalent resistance across edges, these 2 points, and then we will find the equivalent resistance across surface, these 2 points, A and F, AB and A and H. Okay. Okay, so let's start. So first what we will do, we will solve it with the concept of equipotential. Okay, so let's try to think which points can be equipotential. So I will see what points are connected to point A. D is connected, E is connected and B is connected. So E, D, B all together can be equipotential. They can be, I am not saying they surely be, but they can be E, D, B. So let's comment about E, D and B. Okay. So first E will come to A, path is R. Then D will come to A, path is R. Then B will come to A, path is R. So this condition is satisfied. This is one box. Now the other box, E will have to go to H, because we are finding the resistance between A and H. So E will go to H, R and R, R plus R. Talking about D, D will go to H, R and R. This is the shortest path, right? It can go like this as well, R and R. Again it will be the same, R plus R. Here also R plus R, R plus R. And B will go to H, B will go to H, R plus R. Or how can it go? R plus R. This is the shortest path only, R plus R. It can't go like this, okay, because there is no resistance involved in between. It can't go like this. There is no resistance there, right? So this is also, these three altogether are same. These three altogether are same. That means E, D, B are equipotential. I hope you have seen the previous video where I have emphasized on the point of equipotential, right? We saw many examples, okay, where it is called equipotential, where it is not called equipotential. So here E, D, B are equipotential, right? So these two things are independent of each other. If we are talking about 3 points, let's just consider 3 points. E, D, B, all of them will go to A. Same path, good. E, D, B, all of them will go to H. Same path, good. Equipotential. That's it. So E, D, B are equipotential. Now similarly, what will happen? What are the points directly connected to H? G, F and C. So similarly, G, F and C are equipotential. You can check as well. Okay. G, F and B. For G it will go to H, this path. F it will go to H, this path. And C it will go to H, this path. Now G will go to A, this path to R. F will go to A, this path to R. And C will go to A, this path to R. Equipotential, right? So these points are equipotential now. So between A and H, after A I have points E, D, B. E, D, B all together. Then I have points G, F, C. Then I have H. So between A and E, look, between A and E there is a resistance. These 3 points are equipotential, no? These 3 points are equipotential, right? These 3 points are equipotential, and other 3 points were this. These 3 points were equipotential, right? So these 3 and these 3 were equipotential, right? So tell me, between A and D I had resistance R, between A and E I had resistance R, and between A and B I had resistance R. So A to D R, A to E R, A to B R. So E, D, B are at the same point. So between A and E I will have R by 3. Are you getting it? A to E R, A to B R, A to D R, R parallel with R parallel with R, R by 3. Now let's talk about this. G, F and C. Between H and G I have R, between H and F I have R, between H and C I have R. So again between these two I will have R by 3. From H to G R, H to F R, H to C R. So R by 3 and R by 3 here. Now let's talk about other points between G and D. So what are the points that I have already considered? This and this and this. Now let's talk about other points. Okay, between G and D, I have R. Between G and D I have one R. So there will be many R like this. So I will write it down in one go only. I am writing it down. One R is there. Okay. Between G and D, one R is there. Between G and E, one R is there. Between G and E, one R is there. Okay. So this is also gone. Let's talk about this. Between E and F, one R is there. Between E and F, one R is there. Okay. This is also gone. Now talk about this. Between D and C, one R is there. Between D and C, one R is there. Now let's talk about this. Between B and C, one R is there. Between B and C, one R is there. And now let's talk about this. Between B and F, one R is there. Between B and F, one R is there. So there are total 6 R. All are in parallel. So totally it will give me R by 6. Right? All are in parallel. It will give me R by 6. And did I miss any resistance? No, I did not miss any resistance. Okay. Let's just remove these points. I did not miss any resistance. So basically this is my final answer. So it will be R equivalent between A and B will be 2R by 3 plus R by 6, 4R by 5R by 6. Okay. All of them will come in series. So 5R by 6 ohm. So this is the answer. Okay. Are you getting this point? Well and good. Easy problem. So that's how you solve it. Okay. Now people will ask me if I can solve it with the concept of symmetry. The answer is yes, you can. Okay. So first tell me what will be the axis of symmetry? Perpendicular to these 2 points, right? Perpendicular to these 2 points. So like just see your room. Between that point to that point, between A and H, you have to cut it down. Between A and H, exactly in between. So seeing the symmetry is a tough task here, right? It is not an easy task. Seeing the symmetry, it will be in 3D, right? We can't really see it. Like I tried to solve it with the concept of symmetry, but I couldn't. Okay, like from A to H, I will cut it down in between. Like many will cut it down like this. I know many will cut it down like this. But this is wrong. Why it is wrong? This is not perpendicular to A and H. This is perpendicular to A and F. That box I made now, this box, it is perpendicular to A and F, not A and H. A and H are in air. A and H are in air. You have to cut it down in air. Okay, so it's not that easy. But between A and F, you can cut it down like this. So this box that I made, that is for A and F. Okay, not A and H. So seeing the symmetry between A and H, it's a very tough task. So let's not solve it with the concept of bisection, okay, or the concept of symmetry. We will solve it with the concept of equipotential only. So whenever I can solve the question with the concept of symmetry, I will certainly tell you. Okay, let's move on to the next question. Let's try solving this first with the concept of equipotential. So tell me, what points do you think can be equipotential to each other? Okay, I think E and D can be equipotential to each other. From A, I can see 2 points, D and E. B cannot be the other point because across B we are calculating only. So B cannot be the point. So E and D. Let's talk about E and D. So E will come to A, resistance R. D will come to A, resistance R. Well and good. Now E will go to B. E will go to B, R and R, 2R, or like this. So 2R, minimum path is 2R. D will go to B, like this and like this, 2R. Both good. That means E and D are equipotential. So E and D are equipotential. I can make it like this. E and D are equipotential. Now from B I can sense C and F. Okay, C and F. Let's talk about C and F. So it will be similar only, right? From C to B it will come R, F to B it will come R, C to A it will go to R, C to B it will go to R. So these two are also equipotential. So I can write it here only. Similarly, C, F are equipotential. Let's think about H and G. So H will come to B like this, R plus R 2R, R plus R 2R. G will come to B, R, R and R. It will take in 3R. For H it will take only 2R, but G it will take 3R. So these are not symmetric, right? These are not equipotential. I think only 2 points are equipotential there. Or you can think of any other points. If you can think, G and H are not equipotential. So that's it, I guess. There are no other points available. So now we will have to make our circuit considering these things. Okay. So A and E and D. Okay. So let's try to make it. From A to E and D. From A to E and D, we will have R by 2. Do you agree with me? From A to E, we have R, and from A to D, we have R. So A to E, we will have R by 2. Then from D to G, we have R. From E to G, we have R. So to G, we will have, this is point G. From E to G, we have R. From D to G, we have R. So R by 2. Between A and G, are we having anything? No, we are not having anything. So this is gone, this is gone, this is gone, and this is gone. Okay, let's consider the point B. Okay, so from C and F, from point B to C and F, we will have R and R parallel. So it will be R by 2. From B to C we have R, from B to F, from B to F we have R, from B to C we have R. Now consider about the point H. Okay, let's consider about the point H. So from C to H we have R, from F to H we have R. From C to F, from C to H, and from F to H we have R. So it will be R by 2. From C to H R, from C to H R, from H to F R. Sorry. From C to H and from F to H, R and R parallel, R by 2. Between A and B we have R. Between A and B we have R. Now between G and H, we are having R. Between G and H we are having R. So did I miss anything? I guess I missed something. Between E and F we are having R. Between E and F we are having R, and between C and D we are having R. E and F we are having R, between C and D we are having R. E and F we are having R, between E and F we are having R, and between D and C we are having R. So R and R parallel, R by 2. Did you get it? E and C, between between E and F we were having R. Between E and F we were having R. and between D and C we were having R, so R by 2, right? So this will give me 2R parallel with R by 2, okay? 2R parallel with R by 2, 2R parallel with R by 2, so 2 into 1 by 2 upon 2 plus 1 by 2, 2 by 5, right? 2 by 5R. Two by 5R. Then we have R by 2 here, R by 2 here, and R here. Then R plus 2, then R plus this R by 2 plus R by 2 plus 2, 2 plus 2 by 5 R. So it will give me R plus 2 by 5 R. So it will give me 7 by 5 R. So my R equivalent will simply be, R equivalent across AB will be R parallel with 7 by 5 R. Basically R by 2 plus R by 2 plus 2 by 5 R. So it will give me R plus 2 by 5 R. It will give me 7 by 5 R, right? So R parallel with 7 by 5. It will give me 7 by 5, 7 by 12 R. This is my R equivalent across AB. Did you get it? Just it was a bit more calculative, but it was easy problem. We just found 2 point of symmetry, okay? Then we just put them here, we put it here, then we just see between A and D, between A and E, R by 2, then R by 2, and we made it like this. Then it will be 2R parallel with R by 2. So 2R parallel with R by 2 will give me 2R parallel with R by 2. Yeah, it gave me 2 by 5R, then R by 2 R. So 7 by 5R parallel with R. So it will give me 7 by 12 R. So this is my final answer. Is that same? Across AB, yeah, 7 by 12 R. That's my answer. Okay. Now the question comes, can I solve it with the concept of, let's just remove those, concept of symmetry. Just a second. So if you try to solve it with the concept of symmetry, what will happen? That line AB, you consider that line in the room, you see that line AB, and you will cut it in between. You will cut it like this, right? So this is well and good. Okay, this is good. You can cut it like this. Now what will happen? It will give rise to a cuboid. If you cut it in between, it will again give rise to a cuboid, although all these points will be same. If this is O, this is O, this will also be O, this will also be O. So between G and O you will have some resistance, between E and O you will have some resistance, between D and O you will have some resistance. Like it will give you, it will be like this. It will make a circuitry like this. This is the points, and then there is one common point from where there is some resistances, this and like this. So it will give rise to this. Okay, then you will have to solve it. So it is also a good method, but again you will like between A and O you need to find the equivalent resistance between these 2 points, between A and O. So then you will have to consider about this point, how many resistance are there, and also this point. Then I guess all these 2 points will come in equipotential. Let's consider this point is E and this point is D. So E and D will be equipotential then, right? Because from D to A same path, E to A same path, E to O same path, D to O same path. Yeah, these points will become equipotential. Then you can reduce it. Okay, then you can think about this point. So there will be calculations. So you can try solving it, but the best method will be to solve with the equipotential only. So you can take it as a homework. You can try to solve it with the concept of symmetry as well. Okay, it will be a good problem. You can solve it with the concept of symmetry. The next problem I will solve with both of the concepts. Okay, so this I will solve with both of the concepts. Okay, with the concept of symmetry as well, with the concept of equipotential as well. So let's first solve with the concept of equipotential. So what do you think? What all points will be equipotential to each other? From A we have D, E and B. So can D and B will be equipotential? Because from D to A the same path is there, but from D to F it has to go R, R and R, right? R, R and R, 3R, but for B only R. So D and B can't be equipotential at least. So I guess E and B can be equipotential. From E to A, R, from E to F, sorry, from E to A, R, from B to A, R, right? So E and B we are talking about. First we will consider about only E. So E will come to A, R. B will come to A, R. Okay, good. Now E will go to F, R, and B will go to F, it is also R. I hope you have remembered the concept of equipotential. Many students do a mistake here. What is that? They consider E to A and then E to F. No, points are different. E and B are different. We will consider both. E will come to A, B will come to A. Same, good. E will go to F, B will go to F. Same, good. That's it. E and B are equipotential. E equals to B I can write. Okay, you will understand. So E equals to B. So what other points can be equipotential? What do you think? I can think of G and C. Try thinking about these 2 points. G and C. G to G will come to A. R plus R. And C will come to A. R plus R to R. Well and good. Now G will go to F. G will go to F. R plus R to R. And G and C will go to F. R plus R to R. Great. These are also equipotential. So C and F are also, G and C are also equipotential. Let's talk about other points as well. Let's talk about D and F. Now D will come to A very fastly. F will come to A with 2R. So I guess only these 2 points are equipotential. Any other point you can see? If you can see any other point, I don't think there is any other point. So again you will have to make diagram and everything and you will get the final answer. So let's do it. A, E, B, G, C. Between A and F we are drawing A and F. So from A, E, B. From A to E, from A to B, R and R, 2R. Sorry, R by 2. These 2 are gone. From F to G there are no resistance. From H to C there are no resistance. From F to H there is a resistance. So from F to H, okay, from F to B there is R resistance, from F to E there is R resistance. So R by 2, right? F to B R and F to E R. So R and R parallel, R by 2. Okay. From F to H we have a resistance of R. From F to H we have a resistance of R. From F to H. So this is gone, this is gone, this is also gone. Now H to G and H to C. G and C. From H to G and H to C, this is R by 2. From H to G and H to C. Okay. Now between E and G there is a R. between E and G there is a R, between B and C, between E and G there is a R, between B and C there is a R. So it will also become R by 2. R by 2. Let's see what we have missed till now. Between D and C, did I make the point D? I didn't even make the point D. Okay, so I will have to consider somewhere it. Let's consider it here. Between D and C, we have, between D and C we have R, between D and G we have R. So R by 2 and R by 2. So R by 2 will be there between G and, from G and C to D. From between G and C to D. Is there anything else I have missed? Between D to A. Between D to A I have R. Between D to A I have a resistance R. It's becoming a complex problem, I guess. Look, this is looking like a very complex circuit. So I guess we can make it better. Okay. By this circuit as well you can solve it, but I don't think you can see some symmetry here. Okay. So just avoid these things like this kind of lines you should avoid. Try avoiding as much as you can. Okay. So I will make it like this. This is point A and this is point F. Okay. And EB is at the common distance now. So I made EB so near to A and EB so far to F, but they are at the common distance, no? A and F, EB are the common distance between A and F. So I will make it like this. Okay. So between F and EB there is R by 2. Okay, you can skip and make it on your own. Okay. So like this was not a very good way to make. And between F and H there is R. Between F and H there is R. So H can be made far away from A because there is no interconnection between A and H, right? And between A and D there is R, right? Because there is no interconnection between F and D, so it can be made far away from that. And between H and D, between H and D there is a common point, that is GC. So between H and GC we have R by 2. And between D and GC we have R by 2. And now between EB and GC, we have R by 2. This looks like a better way, right? And across that we have to calculate the equivalent resistance. Now you can see one thing here. What is that? That this is acting as a Weisstone bridge, because this is 3R by 2 here, this is 3R by 2 here, this is R by 2 here, and this is R by 2 here. 3R by 2 into R by 2, R by 2 into 3R by 2. This is a Weisstone bridge. So you can neglect this R by 2 resistance. Okay. So basically what will happen, 3R by 2 and 3R by 2, it will become 3R. This R by 2 is gone. So this is 3R by 2 and this is 3R by 2. It means it will become 3R, and 3R parallel to R. Basically this R by 2 is gone. So it becomes R. This is F. This is A. And this will become, here it will become 3R, right? R plus R by 2 plus R by 2 plus R. So it will become 3R. So between A and F, you are getting 3R by 4 resistance. R equivalent will be 3R by 4. Did you get it? Okay, we made it like this initially, but then we realized that this is not a good way of representing the circuit, because we can't really see the symmetry, we can't really see the Weisstone bridge. But here I can clearly see the Weisstone bridge if I look like this. R by 2, 3R by 2, 3R by 2, R by 2. So 3R by 2 into R by 2, R by 2 into 3R by 2. So this is the Weisstone bridge is there. So R equivalent is 3R by 4. Now method 2, because I told you that I will solve it with both of the method, that is concept of symmetry, or concept of bisection, or concept of symmetry. Or bisection. Okay, let's just copy that circuit here. So this is our circuit. Now this is the axis along which we have to cut. This is the axis along which we have to cut, and we will cut it like this, right? We will cut it. Just see in your room, this is the axis, like this is the axis, and you will cut it like this from upside, or you can see in the diagram as well. This is the axis and you are cutting in between like this. Right? You get it? So we have a point A, then you are cutting it in between like this. So all this point G, C, D and B will come at one point. G, C, B and E. Okay. And yeah, now we will try to write it down. I think I should move on to the next page. Okay, we should move on to the next page now. Okay, so we are having A and F, then in between, like from F, in between, this is the, these 3 points are there. From F, EB and E and B are at equal distance, and from A, E and B are equal distance, and E, B and GC are only one point, same point are. So E, B, G, C. So between A and E and between A and B, there is R. So it will be R by 2. Right? Between F and E, between F and B, there is R. So it will be R by 2. Right? Now, so this is gone, this is gone, this is gone, and this is gone. So all 4 are gone. Now between G and E, this will also be gone because both are same point now. Between B and C, this is also gone because both are same point now. Now there is a point H and there is a point D. So A is near to D. A is near to D. So I will write down D here and I will write down H here because H is near to F. So between F and H, there is R. So this is gone now. Between H and F, there is R. Between H and F, there is R. Between A and D, there is also R. Right? Okay. So between A and D, there is also R. Now between G and H, there is R. Between G and C, there is R. Between G and H, between G and H, between G and H, there is R. G and H and G, H and C. H, G and C. So from H, H, G and C, R and R. So it will be R by 2. Right? And then between D and G and D and C, D and G and D and C, there is again R by 2. Between D and H, between D and H, there is nothing. Between D and H, there is nothing. So how much are left now? Between E and F and E and B, that is gone. Look, I have made this now. This is looking so complex, so I can't really see how much are there. Let me check. So 2 to 4, 6, 8, 9, 10. 2 are left. Which 2 are left? Okay, that's it. Nothing is left because two branches are gone now. This is gone and this is also gone. 2 branches are gone, right? Between G and C, between G and E and between C and B, 2 branches are gone. So all 10 branches are there. Okay, so that's the final circuitry. So these 2 are in series and parallel to this one. So 3R by 2 parallel with R by 2. It will give me 3R by 8. And then your R equivalent will simply become 3R by 8 into 2. That means it will be 3R by 4. Actually, this one is simpler than this, or you can solve it by this method as well. But here just this two branches are less, because branch between C and B is gone, branch between E and G is also gone. So two branches are less here. So two branches are gone here. So this becomes a problem of time branches only. And here you can easily see that 3R by 2 parallel with R by 2, it will give me 3R by 8. And similar thing is happening at this side. So 3R by 8 into 2, so 3R by 4. So that is my final resistance. So this is what we have seen in cube. Okay. So in cube problem, we have seen three things: across, diagonal. If now they are asking between A and H, if they ask from G and B, answer will be same, 5R by 6. Now here they are asking between A and B. If they are asked it between E and F, or between G and H, or between D and C, across edges, if they would have asked, the answer would be same, 7R by 12. Now they are asking between A and F. If they have asked between E and B, or between G and C, or between D and H, the answer would have been the same. That will be equals to 3R by 4. So across diagonal of a surface, the answer would be 3R by 4. So you don't need to mug it up. You can simply calculate it whenever they ask, right? And here also I solved it with the concept of symmetry as well, with concept of bisection as well. In other problems, you can try solving that on your own. You will be able to get the answer. Okay. So yeah, this is the complete concept of that finding equivalent resistance. Okay. Now we will see how to find the equivalent resistance in infinite ladder. If there are infinite resistance, how we will find the equivalent resistance, that we will see. Okay. In the next video, we will see that. Okay. Thank you.